Hello there. In this video, I really quickly want to prove the addition identity for tangent. So we're going to first turn this into sine and cosine. Okay, now I'm going to take the identities that exist for sine and cosine and write them out. Okay, so the trick for this will be to turn this into tangent x, and then this to turn into 1, and then so forth and so on. You'll see what we'll have to match the terms up to. Well, to get this to become 1, we have to multiply by 1 over cosine x times cosine y, and this is happening to all terms. 1 over cosine x times cosine y. Well, we'll see that'll cancel with that, and then the other cosine x will cancel with this. And of course, if we wanted to prove the subtraction identity, then we put a minus there, we put a plus there, because we can see as we go through, the signs will follow through. It would be effectively the same proof. Let's go ahead and prove the cotangent angle identity now, and you'll see it looks similar to what tangent was. So let's go ahead and start by writing this in terms of sine and cosine. Next, we're going to write out the angle addition identities for sine and cosine. So taking a similar approach to what we did with tangent, we now need to create cotangent. So instead of dividing everything by cosine x over cosine y, we need to get this to be 1. So we're going to divide everything by sine x over sine y. So these will cancel and become 1. This will be over sine x sine y, so this will get canceled. We'll have cosine y over sine y, so cotangent y plus the sine y will cancel this time, and we'll get cotangent x. Now, and of course, if we wanted our difference identity, we just go ahead and switch all the signs, and we're done. So I've never actually seen an addition identity for secant before, so let's see if we can get it here in this video. So I'm going to start by writing it in terms of cosine. Now let's go ahead and write the addition identity for cosine. Now this isn't quite a satisfactory answer because we have secant in terms of cosine and sine. Let's see if we can get it in terms of secant and cosecant. So I'm going to go ahead and multiply everything by cosine x and cosine y, or divide rather, and that'll be both top and bottom. Now the problem with that is this will become 1 and this will become a tangent. So let's also multiply everything by, while this will cancel, we'll get 1 times here, and we'll get, and then minus, this will cancel out, and we'll just be left with 1 over cosine xy. So keep in mind, these also have to go in the numerator, so we just effectively have wanted a subtraction identity, then we would go ahead and put a plus there, and we're done. Let's go ahead and get the addition identity now for cosecant and complete the set. So I'm going to start by writing it in terms of sine. Let's go ahead now and get the addition identity for sine. Like secant, let's go ahead and see if we can put this terms of cosecant and secant. So let's go ahead and multiply everything by 1 over, and that's both top and bottom. We'll get this and this to cancel out, but we'll effectively just be left with cosecant y times secant x, and then it doesn't take much to imagine that we'll be left with cosecant x times secant y. And of course, when we do that to the numerator, we end up with the exact same numerator that we did in the secant video. So that'd be, of course, if we wanted the subtraction identity, we just go ahead and change everything, and we are done.